Assuming stargazers have found something with our eye overhead, the James Webb Space Telescope, what is it? Are we actually the only ones in the universe? This is an old question, and the James Webb Telescope has discovered a few frightening things that seem to be incredibly far away from Earth. These disclosures assist us in getting closer to the answer. Each civilization has had many people searching for life beyond themselves. There are an enormous number of books, films, and ideas about this point. We've always been curious about where we fit in the world and have often felt alone. It's as though we're wired to constantly search for a companion, regardless of how alien they may appear. It's possible that we're drawing nearer to the answers we truly need. They may be the very answers we're searching for. But are they, in fact, that frightening? Come with us as we explore the latest discoveries in the realms of galaxies and planets, searching for something we might not be ready to see. Researchers have discovered something that may be the most important finding ever. When the James Webb Space Telescope was set to launch in 2021, a very interesting question was raised about what our technology could do. The question was whether our telescopes would be able to find man-made light on a different world in the future. The closest exoplanet to Earth, Proxima B, is in the habitable zone of Proxima Centauri, the small star that is near us and 4.25 light-years away. However, Proxima B is multiple times farther from its star than Earth is from the Sun. It was thought to be tidally locked, meaning it has a day side and a night side, much like how the Moon always faces Earth from the same side. A hypothetical civilization on Proxima B could use photovoltaic cells, which convert starlight into power, to move heat and power from the day side to the night side. In a study that included Manas Lingam as a scientist, it was shown that future telescopes would be able to detect that solar panels cover a significant portion of the day side. It would be possible to search for artificial lights on exoplanets like Proxima B that could support life. Because the James Webb Space Telescope is more advanced now, in 2024, it's possible that it has already detected the lights we were searching for with its better sensitivity and broader scope of capabilities. This could have accelerated the next big step in human development. First, though, let's learn more about planets and exoplanets to understand how all this is possible. James Webb's job is to figure out what Proxima Centauri b is concealing. People have always been fascinated by the idea of the universe. As soon as humans became aware of themselves, they began to try to answer the common yet extremely difficult questions. What are we? Where do we come from? And where are we going? Despite the fact that technology is constantly improving, it makes you wonder whether we are any closer to answering these questions. After all, a philosopher might say that our understanding of ourselves and the universe is still at a level 0. If you ask an astronomer the same questions, they will respond with excitement as they hurry to tell you about the latest, cool discoveries humans have made about the universe. The average person doesn't pay much attention to these tools, but they are really proof of how far humanity has advanced. Now that we can reach the universe with our fingertips, it's time to reach the sky as well. Researchers and scientists have figured out one way to do this. We use technology. The latest discovery, whether there is light on another planet light-years away, is due to a particular piece of that technology, the James Webb Space Telescope. Of course, the James Webb Space Telescope was made possible by the work of those who have already gone into space to find answers to questions that never go away. Are we alone? Who else is out there? Where do we begin and end? Well, this infrared observatory has already started to answer some of these questions. That being said, you may first wonder, what is Proxima B? Proxima B is sometimes called Alpha Centauri b. It is a super-Earth planet that orbits an M-type star. A super-Earth planet is one that is larger than Earth but lighter than ice giants like Neptune and Uranus. These planets are quite special. They can be made of gas, rock, or even a mix of both. Their sizes range from 2 times the size of Earth to multiple times its mass. Now that's what you call a super-Earth. Proxima B is both a super-Earth and exoplanets imply that they are planets beyond our solar system. The first potential indications of an outsider were considered in 1917, but they didn't capture much interest or recognition. Scientists were surprised when they made their first positive detection in 1992. The fact that there was yet another discovery was shown in 2003. This new exoplanet was different from those observed in 1988 and 1989. As of April 1, 2024, there are 5,653 known extrasolar planets in 4,161 planetary systems. 89 of them have more than one planet. These astonishing discoveries are currently orbiting an M-type star. Before discussing the M-type star, you need to know about the red dwarf. The name comes from the fact that a red dwarf is the smallest type of star in the main sequence. The most common type of star in the Milky Way is by far the red dwarf. These stars are found relatively close to the Sun, but they don't emit much light. Since brightness is one of the main ways we detect planets and make other kinds of assumptions, observing red dwarfs is difficult. Depending on their luminosity and size, these subtle stars have unique implications and names. Some examples are M-dwarfs and M-type main sequence stars, which have a maximum temperature of 3,900 K. This is where their names and characteristics originate. When we return to Proxima B, we know that its mass is equivalent to 1.07 Earth masses. It's fascinating that one orbit of its star only requires 11.2 days, while our own takes 365.25 days. You can imagine how small the star that Proxima B orbits is. This star is only about 0.16% as bright as the Sun when considering the entire electromagnetic spectrum. The brightness appears to dim even further in the visible light range, where it looks fainter because it emits much less light energy than the Sun. It only illuminates 0.056% of the Sun's brightness in the visible light range. Over 85% of the energy it emits is in the form of infrared light. The discovery of Proxima B, which orbits 0.04856 Australian dollars from its star, was announced back in 2016. Your question may be, why Proxima B? There are millions of stars, planets, and galaxies in the universe, so why is this one so interesting? Well, there are a few things that make scientists very curious about this location. Proxima B is the closest known star to our Sun, which means it is also the closest star to Earth. 4.2 light-years is a large distance, but in the grand scale of the universe, it's just a blip. Because of this, Proxima B is very significant to us. Moreover, it is a part of the Alpha Centauri triple star system. Even though Proxima B isn't particularly bright, the system as a whole is one of the brightest in the night sky, coming in third after Sirius and Canopus. The most intriguing thing about Proxima Centauri B, however, is that it may be possible to live there. Since this star is in the habitable zone, there are many possibilities surrounding it. That's why astronomers are eager to study the farthest reaches of what this star can offer. The James Webb Space Telescope, JWST, can assist with that. The JWST's four main objectives are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, study how galaxies structure and evolve over time, learn more about how stars and planets form, and explore planetary systems and the origins of life. From SETI to exoplanets, these efforts are getting closer to their goals of discovering extraterrestrial life. The JWST is still investigating the exoplanet in question. People might wonder what SETI really is. Humans have always been naturally curious, poking and prodding at anything that moves or doesn't move. This is why SETI became a major endeavor. Envision that God has arranged a major expedition in space. However, there's a catch. Rather than gold, we should be watching out for signs or, more explicitly, electromagnetic murmurs from societies that are beyond our greatest dreams. SETI represents the search for extraterrestrial intelligence. It is our gathering's mission to find signs of intelligent life beyond the stars. We're continuously inspired by individuals like Nikola Tesla and Guglielmo Marconi, who came up with a novel idea in the early 1900s. Not long after radio became useful to people, they were bold enough to imagine that these new devices would allow them to reach out and contact the stars. Tesla was so excited about the idea that he even thought his wireless broadcast system could be used to talk to Martians. As we move forward to the 1960s, we find ourselves in the midst of Project Ozma, which was created by the courageous scientist Frank Drake. He scanned the radio waves of space for signs of life with a big radio telescope and a lot of curiosity. He worked hard, but unfortunately, nothing came of it. Nonetheless, the search continued, with scientists all around the world tuning in their antennas to hear the vast cosmic music. Meanwhile, our friends in the Soviet Union, behind the Iron Curtain, were also interested in the conversation about space. Led by the great Iosif Shklovsky, Soviet scientists pointed their antennas up to the sky, attempting to catch those elusive messages from space. The stage was set for a space race. Then, something strange cut through the background noise of space, making everyone very nervous and sparking much chatter: the wow signal. It stunned scientists around the world. As the years went by, the search for alien friends in space grew stronger. Scientists spared no effort in their quest to unravel the cosmic mystery. From the small SETI project to the massive Project Cyclops, the dedication was immense. By some strange twist of fate, or perhaps destiny, a coded radio transmission from Mars appeared on our Hubble cameras, which intrigued us even more. But what does exploration look like now, and how far have people come in terms of space travel? In the 2021 research paper Detectability of Artificial Lights on Proxima B, Alyssa Tabor and Abraham Loeb examined whether it would be possible to detect artificial lights from the dark side of Proxima B. Since Proxima B is a planet in the habitable zone of its star, the study sought to determine if it could support intelligent life and how to detect it. After discussing the importance of Proxima B as a target in the search for alien life, they delved into a fascinating and slightly eerie reality. A potential radio transmission was recently received from Proxima B. Though it was received yesterday, it's not exactly new. But in the context of space exploration, where data travels at the speed of light, anything is a breakthrough. There was much excitement among scientists and astronomy enthusiasts about the possible radio signal, which added another layer of mystery that astronomers couldn't wait to unravel. Scientists with the Breakthrough Listen project received the signal, which might be an alien radio transmission coming from Proxima Centauri, the host star of Proxima B. When it began in 2015, the Breakthrough Listen project aimed to search the sky for signs that could point to technological societies beyond Earth. This project involved using state-of-the-art radio telescopes and data analysis methods to explore a very large portion of the electromagnetic spectrum for unusual messages that are hard to explain by natural events. Many years were spent on this search. Concerning the possible radio transmission from Proxima B, the story is highly significant. As part of the project, astronomers detected a narrowband emission with a frequency of around 982 MHz. People typically associate artificial radio transmissions, like those used for communication on Earth, with this frequency band. This exciting discovery opened up a multitude of new possibilities. The finding is still a major milestone in human history, even though the signal hasn't been officially linked to an alien source and might have other possible explanations. Now that the signal was in place, it was time to examine it more closely. The Breakthrough Listen team carefully took additional readings and analyzed the data. The goal was to determine the likelihood that it originated from another planet. Although the signal has been examined extensively, no definitive conclusions can be drawn at this time. The universe, a vast and empty place, is not as straightforward as we would like it to be. The results can be affected by countless issues, disturbances, and interferences from sources on Earth. Astronomers, on the other hand, cannot proceed with faulty data since space missions require great caution and cost a significant amount of money. Mistakes are not an option. While the answer is not yet clear, there is always a light at the end of the tunnel. With the technology we have now, we may be closer than we think to uncovering the mysteries of the universe. The paper emphasizes how important artificial light could be as a sign of technologically advanced societies using lights as beacons. The study proposed that our missions could become even more advanced if we used this kind of technology. Since Proxima B is tidally locked and has a permanently dark side, it would need artificial light for technology to thrive there. The study calculates the light curve by analyzing various factors, including the planet's size, the radius of its host star, orbital period, albedo, and orbital tilt. This is done to estimate how easy it will be to detect the artificial lights. It also discusses how to use the Exoplanet photometric reflected light curves, LORD model, to determine light curves. This is accomplished by adding a measure that shows the amount of artificial light on the dark side of Proxima B. The study then models signal-to-noise calculations with the help of the James Webb Space Telescope's NIR-SPEC instrument to see if detecting artificial lights is possible. The findings were analyzed, showing that the James Webb Space Telescope should be able to detect LED-type artificial lights that produce about 5% of the star's luminosity with around 83% certainty. An 85% confidence level is a significant improvement from previous inconclusive results, although the current spectral band needs to be about 10 times narrower to capture artificial light levels on Earth. At this point, the main idea is that Proxima B's permanent day and night sides might possibly be illuminated with strategic mirrors. This clever approach could make it easier to spot artificial lights. The final part of the study suggested that the work could be expanded in the future. Although we don't know what the future holds, utilizing upcoming telescopes like LUVOIR could be a huge step forward in better identifying the atmosphere of Proxima B. It's amazing to think about how we could handle such complex mathematics millennia ago. Getting to the moon once appeared to be an insane dream. Now we can figure out, work on, and dissect planets light years away, and we can do it well. Our instruments, particularly the James Webb Space Telescope, JWST, are among the most remarkable indications of how far humanity has come. The JWST will significantly impact how we think about the climates and environmental elements of different planets. Yes, that includes Proxima B too. These ambitious plans rely on its advanced observation abilities. The Near-Infrared Spectrograph, NIR-SPEC, is one of the most essential instruments on the JWST. It's a vital component in discovering, categorizing, and ultimately understanding the atmospheres of various planets. NIR-SPEC achieves this through its extreme sensitivity and high spectral accuracy. Astronomers can even split the light from distant exoplanets into smaller pieces, almost like separating two strands of hair. This allows for the detection of critical gases in the atmosphere, like carbon dioxide, methane, and water vapor. And as the saying goes, where there's water, there's life, almost always. After facing the massive waves of the water planet in Interstellar, the characters might have developed a different opinion on that saying. Some people might think we have a magic wand, given that what we do could appear as magic to them. Usually, this in-depth spectroscopic study provides valuable information about the atmospheres and possible habitability of exoplanets like Proxima B. The JWST's mid-infrared instrument, MIRI, is like an extra set of tools for researchers. It enables new ways to study the atmospheres of other planets. The imaging and spectroscopic capabilities of MIRI work in the mid-infrared portion of the electromagnetic spectrum. This allows scientists to explore the heat emissions from exoplanets and analyze their temperature profiles, cloud formation, and atmospheric movement. It's possible that these investigations will help us better understand the universe and, eventually, manage it. By combining data from NIR-SPEC and MIRI, scientists can fully grasp the structure and makeup of Proxima B's atmosphere. Furthermore, the JWST's unmatched sensitivity and observational powers allow astronomers to detect and analyze Proxima B's faint signals, a challenging task given the brightness of its host star, Proxima Centauri. Thanks to technology like the JWST, we can work around these limits. With the telescope's state-of-the-art instruments, even small changes in the light that the exoplanet emits or reflects can be detected. These subtle differences hold the keys we need to learn more about Proxima B's surface features, temperature, and potential signs of geological or atmospheric activity. The JWST is prepared to examine more than just Proxima B's atmosphere. It will also study its orbital elements, surface characteristics, and possible interactions with its host star. With this technology, we might truly determine whether Proxima B is a suitable place to live. According to a 2018 study on the habitability of Proxima Centauri B, the most crucial detail discovered about Proxima B's environment is that it's incredibly bright. The study found that the intense luminosity of its M-dwarf host star poses the most significant threat to making the exoplanet uninhabitable. M-dwarf stars have less mass, which means their pre-main sequence phase can last up to 1 billion years longer than stars like our Sun. They are exceptionally bright during this phase, much brighter than they will be in their main sequence stage. It's been observed that this very luminous pre-main sequence phase poses a significant problem for terrestrial planets forming in the habitable zone. Because the high levels of radiation emitted during this stage can quickly vaporize oceans, just like being zapped out of existence. It can also strip lighter elements from the atmospheres of planets still in development. Scientists ran simulations showing that Proxima Centauri B would have had to wait about 169 million years after formation to become safe. With this new information, it seems unlikely that Proxima B would be a good place to live. The search for extraterrestrial life continues through the James Webb, whether by studying space signals, artificial lights, or super-Earths. The world of space exploration is both thrilling and uncertain, and research in this field is moving at light speed. It might not be long before ordinary people can walk around on the moon. NASA and private companies already have their sights set on the moon. The Artemis program at NASA aims to build a base where people could live on the moon by 2025. This is a bold yet exciting goal. The dream of living on the moon's surface for extended periods is undoubtedly ambitious, but it's also crucial. Pursuing such major objectives allows NASA to pave the way for even longer and more distant space missions with humans. Who knows? Maybe one day this will include a mission with people on board. Elon Musk certainly seems to believe in this vision, as he can't seem to stop thinking about putting humans on Mars and making them feel at home there. Musk's company, SpaceX, has even announced that they intend to colonize Mars, a very human ambition. They aim to use the Starship launch vehicle to accomplish this and believe that humanity needs a colony on Mars for survival. Humanity has shown that not even space can stop us from advancing. The future holds some intriguing mysteries about space that may one day change how we see it completely. What do you think? Are we on the verge of finding extraterrestrial life? Share your thoughts and feelings below.